Welcome everybody. Today we will start with electronic configuration lesson part 2. If you need to look at the electronic configuration part 1, you can go to the link in the description box down below. And now let's start. The first thing that we have to start along the previous class that we introduced you how to write the electronic configurations of an atom using the 1s notation. And now we will introduce you about another concept, which is the atomic orbital. So the atomic orbital here represents those squares in here, and each subshell, like subshell S, subshell P, D, and F, contain atomic orbital. So what you should know and put in your mind for S subshell, it contains only one atomic orbital, which means one square in here. And for the P subshell, it contains 3 orbitals. For D, it contains 5 orbitals. And for F, it contains 7 orbitals. So we can consider those atomic orbitals like rooms. Each room has a capacity of 2 electrons. So at that point, you can conclude that if we want to fill electrons in the s orbital, we can put 2 electrons. We represent those electrons in terms of arrows. So we have arrow up and arrow down. And the reason behind the arrow up and down, put in your mind that the electrons in the universe, they spin around themselves. They may spin clockwise or anti-clockwise. We represent the spinning with the clockwise as an arrow up, and the one that is anti-clockwise is in form of arrow down. If you ask yourself, why do we have 2 oppositely spans electrons in one atomic orbital? Because we have repulsion between these 2 electrons. And the best way to reduce this repulsion is spinning in the opposite directions. If you go to the p orbitals, if I ask you, for example, to fill those p orbitals in here, like we have a 3, 1, 2, and 3. If I ask you to fill those electrons, we represent the filling like this, 1 up, and we go to the second orbital, and then the third, and then we pair them up. And there was a scientist who proposed this theory, and his name is Hunt, and he said that you should have fill the orbitals by single electrons and then pair them up. And that's why this is the best technique to write the electronic configuration and filling those electrons. And the same story here is repeated with the orbitals. We start filling the d orbitals by 1, 2, 3, 4, 5, and then we pair them up like this. We want to recall that again, like the 2 opposite spinning electrons come as a result of decreasing the repulsion between the 2 identical charges, which are electrons. And by the way, the same thing is repeated for the F subshell. We have 1, 2, 3, 4, 5, 6, 7, and then we pair them up like this. And now we have to count how many electrons we have in overall. So as you can see, since we have 7 atomic orbitals with 2 electrons occupied, we have 14 electrons, and this is the maximum capacity of F subshell. For the d orbitals, we have 10 electrons as a maximum capacity. For the p orbitals, we have 6 electrons, and for S, we have only 2 electrons. And now, let's go to the second question. If I ask you to fill those atomic orbitals with corresponding electrons in manganese atom, which has 25 electrons, I don't need you to write the whole filling of those electrons in their atomic orbitals. I'm just like focusing on the third shell that contains all what we need actually in addition to the 4s. My question is, how can I draw the electrons inside these atomic orbitals based on the electronic configurations that is given to you? You have to fill those electrons like this way, and then we have to 3p, we have to fill them by 6 electrons, we have to say 1, 2, 3, and then 4, 5, 6. And then we got to the 3D and we have 5 electrons. We put them like this, 1, 2, 3, 4, 5. And we have to go to the 4s, which has 2 electrons at that point. And I want to ask you now some questions. If I ask you how many electrons are in the S subshells, like in overall, based on the manganese atom, for sure, I need to know about the number of electrons in the p orbitals and subshells, and actually it's based on all of these questions are based on manganese atom, and I need to know about the d orbitals as well. So first of all, you can say like, oh, we can say that the S contains 2 electrons and that's why we have 2 electrons, but the answer is not right. I'm asking you about all of the electrons in all S's that you have, which means that we have the first S in here, we have 2 electrons from the first S, and we have another 2 electrons from the 2S, and we have another 2 electrons at 3S, and we have another 2 electrons from the 4S. And that's why the overall number of electrons in S subshell is equal to 8 electrons. And the same thing is repeated for p orbitals. Let's go. How many p orbital we have? I just want to use another color. Let's use this one here. Yeah. So here we have p orbitals. The first one here, we have 6 electrons first, and plus we have another p orbital which contains 6 electrons. The atom is 12. And if I ask you about the number of electrons in the d orbital, which is very easy, we have only 3d in here, and it's not repeated anywhere. And that's why we have to say that we have 5 electrons for D.